Your so your test is going to be on Monday. It's over chapter 4. Does that mean that you're not going to have any problems from your previous chapters? No. All the tests in here are cumulative, meaning that they can have stuff that you did on the first couple chapters. Let's look at the homework assignments that are going to be due for your notebook check. It's all of these chapter 4 assignments. There's not that many. We had chapter 4, 1 through 8, 9 through 15, and 41 through 44, 16 to 23, and 28 to 36. Okay? So these are the things I'm expecting to see in your notebook. I'm looking for these 4 assignments. Make sure that you have those ready to go for me on Monday. Okay, so we're inside the book. Let's look at this first section, see how things go. First section, we had these. A skydiver falling downward through the air at a constant velocity. These are just making free body diagrams. I think most people did really good on this section, but these are definitely going to be on the test. Whether they're standalone questions or whether they're questions that are partial credit for drawing the free body diagram correctly, things like that. So make sure that you know how to do these. Is there one of these that y'all would like me to go over with y'all? Number 5? Hey, I can do number 5. Copy. Okay, so I need to make a free body diagram, and I got to do some labeling. So I'm going to come over here and grab these directions. Now I'm hearing too much talking back there. Y'all might want to quiet it down. Okay, so I need to specify the system. So if I catch a ball in my hand and bring it to rest, what is the thing that I'm going to be looking at when I make this free body diagram? What's my system going to be? The ball. Okay, so I'm going to have the ball. Make sure to draw the ball. Okay, so that's the ball, right? Yep. Okay, so now I got to think what's happening to the ball. And what? Falling. It's falling. So I got the ball. It is falling, you say, right? Okay, so is anything touching it before? No, so while it was falling, it was acting under gravity, right? Which is Fg. Or you could call it the force of the earth on the ball. Now it says you catch the ball in your hand, so is something touching the ball? Your hand. So which way is that force going to go? Goes up. This is the force of the hand on the ball. Okay. Which of these arrows should be longer, the hand on the ball or the earth on the ball? You think earth on the ball? Well, let's see what we're doing real quick. So if I'm catching the ball in my hand and bringing it to the rest, so my velocity was going which way? Down. But is it speeding up or is it slowing down? Which means that my acceleration must be which way? Up. Remember, if it's speeding up, it's the same direction for velocity and acceleration. If it's slowing down, they're the opposites, right? Okay. So it says, specify the system. So the system was the ball. Draw a motion diagram and a free body diagram. So let's do the motion diagram. It's falling, but it's going to get closer and closer together. So up at the top is the initial, down at the bottom is the final. All right, back to recording. All right, so indicate the direction of the acceleration and the net force. So remember that the net force is always in the same direction as the what? Is the net force in the same direction as the velocity or the acceleration? The acceleration. So acceleration is up, so that means that the net force is also up. All right. Acceleration and force. We talked about that when we got into the second law. So someone asked if we could look at number 11. But I will tell you that 6, 7, and 8, they're easy, but they're also good test problems. Yep, the acceleration and the net force are always in the same direction. If it's 0, no direction. All right, so someone asked to look at number 11. So number 11 is pretty good. Because number 11 is one of those ones that combines the things from chapter 3 with the things from chapter 4. And I told you that I'm going to do that on the test, right?
Right.
Yeah. Okay. So 2 horizontal forces are exerted on a large crate. The first force is 317 newtons to the right. The second is 173 newtons to the left. Draw a force diagram for the forces acting on the crate. Just for the horizontal forces, no up and down forces. Okay? So for my given, I start by drawing my free body diagram. That's the crate. And it says the first force is 317 newtons to the right. And it says the second is 173 newtons to the left.
Bethany Peña to the front office, please. Bethany.
All right, so I've done part A. Part B says, what is the net force acting on the crate? So the unknown is net force. Remember that to get the net force, what you're going to do is sum all the forces on my free body diagram. So to get the net force, I have F net equals 3/17 to the right. So is that positive or negative? Positive. 317. 173 to the left. Positive or negative? It's 144?
Yeah.
That's believable. 144 unit. Newtons, direction, right. In my final answer, I always put the direction. Yes, I will take off if you don't put the direction in your answer. All right. Letter C. It says that the box is initially at rest. So what is that telling me? If it says it's at rest, what does that mean? No, it's not saying anything about acceleration. It means it's not moving, which is telling me what? What's 0? The acceleration ain't 0? Velocity. So when it says that it's initially at rest, that's telling me that the initial velocity is equal to 0. It says 5 seconds later. So what's 5 seconds? Delta T. Ooh. I put 5.0. That one's written out as a word. Don't base your sig figs off of it. Okay? Its velocity is 6.5 meters per second. So that's telling me what? Velocity what? V final? 6.5 meters per second. It says, what is the crate's mass? So the unknown is what? Mass. Well, I don't know of an equation that has V final, V initial, delta T, and mass. Do y'all?
I mean, like,
So what equation that we've talked about has mass in it?
you know the F net.
Okay, so we know that F net is equal to the mass times the acceleration, right? F net equals ma. Okay, so I already have F net, right? I'm looking for mass. Is there an equation that relates the acceleration to V final, V initial, and delta T? Yeah. That was one of the first things that we did. Acceleration is equal to V final minus V initial divided by delta T. Okay, so we'll solve this second equation and then plug it into the first equation. So the acceleration is V final, which was 6.5, divided by, I'm sorry, minus 0, because y'all like me to put all the numbers in there, divided by 5 seconds. So what's 6.5 over 5? Y'all got 1.3? Ugh. I don't think I've ever had it do that. .3, just like you said. And then, what's the unit for acceleration? Meters per second squared. All right, so now I've got A. I can plug it into this equation. So F net was 144 equals M times 1.3. So what's happening to the M? Being multiplied, so I need to divide. Divide both sides by 1.3. So 144 over 1.3 is what? Okay, so I got that the mass is equal to 110.769. Let's check my sig figs. Look at my sig figs. How many were here?
3.
How many were here?
2.
2. So when I come to round, I got to round to the right number of sig figs. That's right. So the mass is going to equal to 110. What's the unit for mass? kg, kilograms. Does it have a direction? No, because mass is a scalar. Don't put a direction on your test on mass. Questions? No questions for that? All right, let's keep going. Because I know there's one I really want to get to. How do you know it's that one? You just know that I really want to look at number 26?
Hard.
No, it's not hard. I know it's a really good question, though. All right. So I don't like that they changed it to where I can't just scroll through this with my mouse. All right, so y'all see 21. That looks like a problem we talked about yesterday, right?
Yeah.
So 21, that's a good question to study, right? Okay. Now you should have one just like it in your notes because we did it as number, what, 51 yesterday? Oh, 52. So number 52 from yesterday looks a lot like number 21 from the homework. But what I want to look at is number 26. Because number 26 is a fun problem. Nope, that's not the one I want. Where's the one I was looking for? The one I'm looking for is one that has tension in it. Maybe it's number 30. Yeah, the one with the tension in the ropes. Oh, here's some that I wanted to look at because people were struggling with this one. But these are gimme questions. Don't mess these up. Okay, so 28 through 31. All of these should be really simple, but people mess them up. So let's look at number 30 real quick. Suitcase sits on a stationary airport luggage cart, like in figure 16. Draw a Freebody diagram for each object and specifically indicate any interaction pairs between the two. So, if I come back over here, you see that we have a suitcase and we have a luggage cart. Okay? So, this suitcase, what's it touching? The cart, right? Is it touching anything else? No. Okay. So, when I do my Freebody diagram, this is my cart, or this is the case. The cart is touching the case and pushing it up, right? So we call that the force of the cart on the case. Okay? And then going down, what do we have? The force of gravity, which we can also say is the force of the earth on the car, or the case, yes. Okay? So that's all we have for the case. Pretty simple for that, right? Okay. The cart is slightly more complicated, but not a lot more complicated. Okay? So this is the cart. What's touching the cart? The case. Is the case pulling the cart up or pushing it down? Pushing it down. So we have that part. This is the force of the case on cart. Okay. In just a second, we're going to see this. Look, it said indicate any interaction pairs between the two. Is this an interaction pair? Cart on case, case on cart. They're opposites. Their directions are opposites. That's an interaction pair. Okay, and then we have, is the cart touching something? What else? What else? Oh, the floor, right? So the floor is pushing the case up. So that's the force of the floor on case. Is that everything that's on this? That's everything it's touching, right? But there's still another force, isn't there? What field force is acting on it? Gravity. So I still have this force going down, the force of the earth on cart. What I was seeing is a lot of people were missing one of these two arrows. So don't forget to include not just your contact forces, but also your field forces. And don't forget to put your phones away while I'm talking. Unless you want me to take your phones. All right. Let's get back into this thing with its horrible, horrible way of scrolling now. No, they changed this book to be Adobe Flash. So now you can't scroll because anytime you scroll, it scrolls itself back up to the top. So you have to click and drag to make it work. Which is quite annoying. All right, so number 36 and number 37 are both really good problems. 36 was a homework problem, right? So let's do that one first, and then maybe let's look at 37. Okay? Copy. So when I look at this one, it says a block hangs from the ceiling by a massless rope. A second block is attached to the first block and hangs below it on another piece of massless rope. If each of the two blocks has a mass of 5 kilograms, what is the tension in each rope? Okay, so I'm going to draw a picture. That's the ceiling. That's a rope. That's a block. And it said it's connected by another rope to another block. That's the situation we have here. Okay? Each one of these blocks is 5 kilograms, so 5 kgs and 5 kgs. What it's asking for us is to find the tension in rope number 1 and the tension in rope number 2. So, the way that you figure out what the tension in the rope is you have to make a Freebody diagram of the system. So which system do I want to look at? Do I want to look at block 1 as the system, block 2 as the system, or block 1 and 2 put together as a system? Start with 1 and 2? Okay, I'm going to have to do it twice. So this is my first system. Okay? So everything in the system I'm going to rewrite as a dot. Okay? So things from the external world that are touching this system is just this one rope, right? Okay? So remember that when I cut a rope, I get a tension, right? So I'm going to call this one T1 because it's the tension in the first rope. Okay? Y'all with me? Okay. Now, what field force is acting on the system? Gravity. So gravity goes this way. And this is Fg, which is equal to what? Mg. And how much mass is in my system right now? Yeah. So there's 10 kilograms. Well, this is my system right now. So the whole system is 10 kilograms. So that's 10 kilograms times gravity is 9.8 equals 98 newtons. All right, so is my system accelerating right now? Is it like flying through the ceiling? No. Is it falling to the ground? No, so that means that my acceleration must be what? All right, so that's all the givens for that. The unknown that I'm solving for is T1. The equation I'm going to use is F net equals M times A. We go to solve. So how do I do F net? I have to go where? My free body diagram. So I got T1 going up. Is that positive or negative? Positive T1. I got FG going down, so that's minus 98 equals the mass, which is 0. Oh, I'm sorry, the mass is 10 times the acceleration, which is 0. So I got to add 98 to both sides. So T1 equals 98 newtons. Am I missing anything? No, I'm sorry, in T1. All right, so I don't put a direction on tension. Because remember, tension is one of those coupled forces. It pulls both directions. So you can say the tension in the rope is 98 newtons. Okay? Now I got to do this other side. So I'm going to do another system. This time I need to cut this middle rope. So you can either cut it this way, or you can cut it this way. Y'all want to do the black one or the blue one? Blue? All right, so we're going to do the blue one, this bottom one. Okay, so now I have a dot is my block, right? Going up, I have T2. Going down, I have FG equals MG equals 5 times 9.8, which is 49, I think. That sound right, 49?
Yeah.
Okay. My acceleration is what? 0. My unknown is T2. The equation, F net equals MA. Solve. I got T2 minus 49 equals 5 times 0. Add 49 to both sides. We got T2 equals 49 newtons. Y'all see how that works? No direction for tension. What I want to show you right now, this last piece, it's already done. We solved them both, but I want to show you that you could have used the black system as well. So if I do that one, going up, I have T1. Going down, I have MG or FG. Sorry. FG equals MG equals 5 times 9.8 equals 49. But I also have T2. Again, the acceleration is equal to 0, right? And then I have, so those are my givens. Unknown is T2. I already have T1. I calculated it before, right?
Oh.
My equation is F net equals M times A. I go to solve. I've got T1, which I already know is 98, right? So 98. I got minus 49 minus T2 equals 5 times 0. I'm going to add T2 to both sides. And I get that T2 is equal to 49 newtons. So I got the same answer both ways, right? That means I probably did it right. Okay? It's a way to check your answer, or it's a way that you can just solve it differently. Remember, there's always more than one way to solve a problem. So if I look at it that way, that's just a different way to solve it. So let's see, second period's out at 34. I think we have time to look at number 37. Yep. So a block hangs from a ceiling by a massless rope. A 3-kilogram block is attached to the first block, hangs below it on another piece of massless rope. The tension in the top rope is 63 newtons. Find the tension in the bottom rope and the mass of the top block. Okay, so it's similar to what we had before, but it is different, right? Okay, so I've got a block, hangs from the ceiling, and then a 3-kilogram block is attached to this one. Okay? They said that T1 is going to be equal to 63.0 newtons. So up here is T1. Find the tension in the bottom rope and the mass of the top block. So, sorry, this is the given all up here. The unknown is T2 and M1. Okay, so I need to figure out this guy, and I need to figure out this guy. How am I going to do it? I don't know. I'm sorry, I need to figure out that guy. What's up? Yeah. Same type of situation. Yeah, very similar. So I'm going to start by cutting this guy right here. So I know that the acceleration is equal to 0, right? Just like last time?
Yeah.
Okay. So I'm going to look at my equation of F net equals m times a for this guy right here. So let me make a free body diagram for him. So going up, I've got T2, right? Up, I've got T2.
Yeah.
Down, I've got FG, which is equal to mg, which is equal to 3 times 9.8, which is a number. $29.4. Okay, so we go to solve. We got T2 minus 29.4 equals 3 times 0. Add 29.4 to both sides. And I got T2 is equal to 29.4 newtons, which I had 3 sig figs before, so that's going to be good. Okay, so now that I've got T2, I can do this guy right here. Okay? I don't know why it's not letting me extend my page. Okay. So my free body diagram for this top one. I've got T1, which was equal to 63 newtons. Going down, I've got T2, which is 29.4 newtons. And also going down, I've got FG, which equals the M, which I don't know, times G, so M times 9.8. The acceleration again is 0. The unknown is is M. The equation is F net equals MA. I can solve. I got T1 going up is 63. I got T2 going down is minus 29.4. I got minus 9.8 M equals 0. Add 9.8 M to both sides. So 63 minus 29.4 is 33.6. So I got 33.6 equals 9.8 M. Divide both sides by 9.8. And you get 3.4285. How many sig figs am I supposed to have? 2. No. 3. We had 3 for our last answer, which we should have 3 for this answer. Make sure you don't mess up your sig figs on the test on Monday. That rounds this to 3.43. So M equals 3.43 what? What unit? kg. Does mass need a direction? No. So what are my things that don't need direction? Mass, time, tension. Everything else, what do you need? Direction. See me after school today if you got questions. Or, of course, you can ask me questions over the weekend by email.